In AI, we spend a lot of time thinking about how to protect our models from outside attacks. But what if the biggest threat isn't outside? What if it's already on the inside? Today, we're talking about data poisoning, a stealth attack that corrupts an AI from within, long before it ever sees the light of day. There's this common idea that more data always makes for a smarter AI, but that's not the whole story. What if the very data you're training on is lying? By the end of this explainer, you'll understand exactly how an attacker can poison that data to secretly embed flaws deep inside a model, effectively turning its own learning process against it. So, here's how we'll break it down. We'll start with what data poisoning actually is. Then, we'll walk through how an attack plays out. After that, we'll look at where the risks are highest in the real world. And finally, we'll cover how you can actually defend your models against it. All right, so let's start with the core concept. What really is data poisoning? Well, it's an attack that goes right for the heart of the learning process itself. So to put it formally, data poisoning is when an attacker deliberately corrupts a model's training data. Now, the goal here isn't to cause just one little error. It's to embed a permanent, hidden flaw into the model's fundamental logic. That flaw then gets deployed right along with the model, just waiting for the right moment or the right trigger to be activated. To really get a feel for how this works, let's use a simple analogy. Imagine we're poisoning a well. In a healthy system, our model is learning from a clean well of data. It drinks this pure water, so to speak, and learns all the right patterns. It's like a student studying from a perfectly accurate textbook. But then, an attacker shows up. And they don't attack the finished product. No, they go back in time to the training phase. They sneak in and add just a tiny amount of carefully crafted poison into that well of data. Now, the model doesn't know any better. It just keeps drinking from this corrupted well, learning the malicious patterns right alongside the good ones. The result is a model that looks and acts completely normal, but has a hidden, intentional flaw baked right into its core. Now, it's really important not to confuse this with prompt injection. They sound similar, but they're completely different. Data poisoning happens at training time. Its goal is to corrupt the model itself. Prompt injection happens at inference time, when a user is interacting with the model, and its goal is just to manipulate one specific output. They target totally different stages of an AI's life cycle. So what does an attacker trying to achieve? Well, there are really two main goals. The first is pretty blunt. Just degrade the model's overall performance, make it less accurate, less reliable. The other is much more surgical. It's a targeted attack designed to cause a very specific failure. For instance, making the model misclassify one particular thing, while it works perfectly the rest of the time. Okay, so how do they actually pull this off? Let's look at two common methods. The first is called label flipping, and it's pretty much what it sounds like. An attacker takes an image of a cat and changes its label to dog. Do this enough times, and the model's accuracy starts to drop. The second method is a bit more sneaky, a backdoor attack. Here, the attacker injects a hidden trigger, maybe a specific word or a tiny visual pattern. The model learns that this trigger is associated with some malicious action, but this flaw stays completely dormant until that trigger appears. And this isn't just a theoretical threat. The risk is very real, and it's especially relevant for the kinds of AI systems we're building today. The biggest vulnerabilities pop up whenever you're using data that you don't 100% control. Think about it. Content scraped from the web, open data sets, or even data from your users. These are all potential entry points because they're hard to fully vet. The same goes for complex systems like federated learning or RAG pipelines, which pull data from many different sources, creating even more opportunities for an attacker to slip something in. This is particularly dangerous for today's large language models. It's often called knowledge poisoning. When an LLM learns from a vast external knowledge base, an attacker who compromises that source can literally teach the model incorrect or harmful information, which the model then repeats as if it were a fact. And the consequences are serious. A successful attack can, of course, degrade accuracy. It can create hidden backdoors for someone to exploit later. But maybe the worst outcome is a complete erosion of trust. Once users believe a model's integrity has been compromised, it's incredibly difficult to win back their confidence. So how do we stop this from happening? The best way to approach this is to think about building an immune system for your models. Building this immunity really comes down to 4 key practices. First, data hygiene. You have to be ruthless about validating and sanitizing any data before it ever touches your training pipeline. Second, continuous monitoring.
Keep a close eye on your model's behavior in production for any strange dips in performance. Third is proactive defense, like adversarial training. This is where you actually show the model poisoned examples so it learns how to spot and resist them. And finally, just good old-fashioned security. Protect your training data with strict access controls, just like you would with any other critical asset.
So, to wrap it all up in a single sentence, data poisoning is when an attacker corrupts training data to embed hidden long-term flaws into a model.
And the most important thing to remember is this: an AI system's security doesn't start at the firewall or the API. It starts with the integrity of its data.